In this video, we will learn how to decompose the total effect of price increase into substitution effect and income effect. The question is, given the utility function of a consumer, that is, utility is a function of two goods consumed, which is equal to under root x times y. We need to find out the substitution effect, income effect, and total effect when price of good x increases from $5 to $10 and price of good y is $2 with income of the consumer given us is $20. Okay, so what we write? So we have this information, utility is equal to, here I have written it, x raised power 1 upon 2 times y raised power 1 upon 2. You know that under root xy can be written like this, xy raised power 1 upon 2, and it can be written like this, 1 raised power upon 2 if I expand it in this form. Okay, you know that is what I have written here. Price of good x is initially $5, price of good y is $2. Because of some reasons, price of good x is increased to $10. I have written here px prime, and also income of the consumer is being given as $20. Okay, we need to find out the price effect and decompose it into substitution effect and income effect using Hessian method. Having said that, okay, so let us learn what is meant by substitution effect, income effect, and total effect. So what will be the total effect? Total effect of price change, it will be because of two factors, what we call the substitution effect, another what we call the income effect. Okay, now what is substitution effect? So substitution effect involves substitution of one good for another good due to change in the relative prices of two goods. Okay, and let me explain it here. In this case, we know that price of good x has increased. If price of good x has increased, that means good x has become expensive in relation to good y. If price of good x increases, means good x has become expensive in relation to good y. That means consumer will substitute good x for another good. Here what we have, y good, that means quantity demanded of good x will decrease. This is what we call the substitution effect. Substitution effect involves substitution of one good for another good due to change in the relative prices. Okay, another effect is what we call income effect. So income effect results from an increase or decrease in consumer's real income as a result of price change. And let me explain it also here. Let us suppose price of good x is initially $10, and let us suppose the income of the consumer is initially $100. So with price of good x is 10, income is 100. Let us suppose consumer spends all income on price on good x rather. So how much quantity will consumer demand of good x? That will be equal to income upon the total price. That is the price of good x. So initially it will demand, he will demand or she will demand 10 upon 100 upon 10, which is equal to 10 units of. So initially price is 10, income is 100, consumer will demand 10 units of good x. Suppose in this case price of good x is increased to $20. Income is again constant 100. Now how much will consumer demand this time? You can see in this case what has happened. With the same 100 units of money or $100 of money, you can see here will be m upon px prime, this new, so it will be equal to 100 upon 20 this time. So quantity demanded of good x will decrease to $5. Okay, what has happened here? With the increase in the price of good x, consumer's real income has decreased. That is why quantity demanded of good x has decreased. Okay, this is what we call the income effect. That is, the income effect results from an increase, in this case, in the decrease in the consumer's real income as a result of price increase. Okay, so simple income effect shows us how much quantity demanded of good any good will change due to the change in the real income. Although we have same income of $100, but this time this same $100 can only be used to purchase 5 units of good X. Nominal income has although been same, but real income has decreased. So total effect of price change has now two components. Okay, and let me explain it again. So change in the price of good X will result into the change in the quantity demanded of good X. But this change in the quantity demanded of good X will have two components. One will be the substitution effect, as I have told you. If price increases, in this case, consumer will substitute good X for another good, or he will so substitution effect will involve if price of good X is increased, good X will become expensive. With expensive good in relation to another good, consumer will decrease the quantity demanded of good X. This is what we call the substitution effect. Another component is the income effect. Okay, because of the increase in the consumer's price of good X, real income will decrease, because M upon Px, that is real income, will decrease. Nominal income will remain same, because if price of good X increases, the real income of the consumer will decrease. If the real income decreases, that means quantity demanded of good X will also decrease. Okay, this is what we call the substitution effect and income effect. Now let's come to the question. How do we decompose it here? For that I need to draw a graph. Okay, please bear with me if I cannot draw the graph properly. This is always a problem with me when drawing the graph. So let us say we have good X on the horizontal axis, good Y on the vertical axis. Now what we need to do, first thing is, first we have to use 3 steps here. First step is we need to find out the initial optimal bundle. Okay, initial optimal bundle at initial prices. Okay, now what will be our endeavor? We will want to maximize the utility of the consumer, which is x raised power 1 upon 2 times y raised power 1 upon 2, and what will be the initial budget line, budget constant, that will be price of good X times units of good X plus price of good Y times units of good Y should be equal to the income of the consumer. Initially price is 5 and 2 for Px and Py respectively, so we can write 5x plus 2y should be equal to the total income of the consumer, which is 20. We need to find out the initial optimal bundle at initial prices. Okay, now how do we solve? We know it pretty well. We have some budget constant, and consumer will try to attain highest utility, and highest utility will be attained at a point where the budget constant and indifference curves are tangent to each other. So what we do, we equate the MRS of good X and Y with the ratio of the prices, price of good X upon price of good Y. Okay, if I do it here, so MRS, as you know, it is the ratio of marginal utility of good X upon marginal utility of good Y, and it should be equal to the ratio of the prices. Here the prices are 5 upon 2, the price of good X and price of good Y. MUX, as you know, it is simply the change in the utility due to the change in the consumption of good X, and MUY is the change in the total utility due to the consumption of good Y, and it should be equal to the ratio of the prices. Okay, du upon dx is simply the partial derivative of the given utility function with respect to good X. How do we take partials? So we see, since we have to take the partial with respect to X, the exponent of X becomes coefficient. So we have 1 upon 2, and exponent is subtracted by 1. So we have 1 upon 2 minus 1, and Y will remain same as 1 upon 2. This is du upon dx. Now we need to find out du upon dy. This time the exponent of Y will become coefficient. So we have 1 upon 2. X raised power 1 upon 2 will remain same, and exponent of this Y raised power 1 upon 2 will be subtracted by 1. If I further solve it, this will get cancelled. So we will get x raised power 1 upon 2 minus 1 is negative 1 upon 2. Then we have y raised power 1 upon 2 upon, here we have x raised power 1 upon 2 times y raised power negative 1 upon 2. because 1 upon 2 minus 1 is this. If I further solve it, if I transpose this y to numerator and this x to denominator, see here what will happen. So initially we have y raised power 1 upon 2 as numerator. Multiply it with, if I transpose it here, exponent sign of y will change from negative to positive. So it will become y raised power 1 upon 2. Likewise, we have in the denominator is x raised power 1 upon 2. If I transpose this, it will become x raised power plus 1 upon 2. Okay, here you can see we have same basis in the multiplication manner. So exponent sign will be same basis, exponents will be added. So we will get y raised power 1 upon 2 plus 1 upon 2, 1 upon 2 plus 1 upon 2 as the exponent. Likewise, here we will get x raised power 1 upon 2 plus 1 upon 2, which will be equal to y. 1 upon 2 plus 1 upon 2 is 1, and here we have also sum of the exponent is 1. We will get y upon x. Okay, so MRS, when I equated with the ratio of the prices, what we got? MRS, I got in place of MRS is y upon x. Now let me rub this out. So we got y upon x should be equal to the ratio of the prices, that is 5 upon 2. Let us solve it for y. So y will be equal to 5 upon 2. Transpose it here, we will get, it will get multiplied. Now plug this value into the initial budget constraint. So what will we get? We will get 5x plus 2 times the value of x is, rather y is 5 upon 2, plug here. So we have 5 upon 2x should be equal to 20. 2 and 2 gets cancelled. We get 5x plus 5x will be equal to 20, or 10x is equal to 20. Dividing both sides by 10, we will get 10 ones are 10 twos are, so x will be equal to 2. Okay, and what about y? Plug the value of x is equal to 2 in this equation. So y will be equal to 5 upon 2 times 2, because x is 2, 2 gets cancelled, y will be equal to 5. Okay, so y is equal to 5, x is equal to 2, and let me write it here. When I equate MRS, I got x is equal to 2, y is equal to 5. This is our initial optimal bundle, and let me show it on the graph also. So let us suppose this is our initial bundle initial budget constraint. Okay, and we got initial optimal bundle at initial prices as 2 and 5, and let me show it here. Let us suppose this is our initial optimal bundle. Okay, I will not draw the indifference curve here because it will get messy. At last I will show you. So let us suppose consumer 2 units of good X here, and we have 5 units. Let us say here we have 5 units of good Y initially. So second step will be to find out. So second step will be to find out the new optimal bundle at new prices. Okay, so our utility function. So again we have to maximize the utility of the consumer, which is x raised power 1 upon 2 times y raised power 1 upon 2 with new budget constraint, that is price of good X which has changed, px prime times units of good X plus py times units of good Y should be equal to the income of the consumer. Now since price of good X has increased from $5 to $10, so in place of p prime X we have 10x, then we have plus 2y should be equal to the income of the consumer, which is 20 here. Okay, again MRS, we have found out initially MRS is y upon x. So again equating MRS with this with new prices, that is px prime upon price of good Y is same. When we do it, we know that MRS will be y upon x, and what will be px? Px is this time 10 upon, I have explained earlier how to find our MRS. Okay, it shows the slope of the indifference curve, and this shows the slope of the budget line. we have this time 10 as the price of good X and 2 as the price of Y. So let us solve. So it will become 5. So we have Y will be equal to, transpose it here, so it will become 5x. Now we plug this value into this budget constraint, new budget constraint. So we have 10x plus the value of y, so we have 2 times the value of y is 5x will be equal to 20. So we have 10x plus 2 tens are 20, so rather 10x again will be equal to 20, which is 20x will be equal to 20, or x will be equal to, dividing both sides by 20, we will get x will be equal to 1. If x is equal to 1, what will be y? Since y is equal to 5 times x, y will be equal to 5 into 1, which is 5. This is our new consumption optimal bundle. Okay, so what has happened here? Since the price of good X has increased, consumer will demand less units of good X. That means our budget line will pivot towards left. And how do I show this? So we will have same intercept, but our budget line will be like this. Let us suppose this is our new budget line. Let us say it is here C. AC is our new budget line. And what has happened here? Consumer is demanding only 1 unit of good X, and let us suppose it is here, this point. Okay, this is the point, and 5 units of good X again. Sorry, 5 units of good Y. Having said that, and let me explain it again. Since price of good X has increased, consumer will demand less units of good X. Initially he was demanding 2 units of good X. Now he is only demanding 1 unit of good X because of the price increase. So here we have 1. Okay, now we need to find out. So total effect, you can see, because of the price increase of good X, consumer has decreased its quantity of good X from 2 units to 1. Now we need to decompose this into substitution. How much of this is because of the substitution effect and how much of this is because of the income effect? So for that, what we need to do, okay, so let me see if I have. Now let me draw the graph again. I am too weak to draw the graph correctly, so let me do one try. So we have good X on the horizontal axis, good Y on the vertical axis. So initial optimal bundle at initial prices was, consumer was demanding 2 units of good X, 5 units of good Y. Okay, so let us draw the initial optimal bundle. So let us say this is our initial budget line, which is AB. On this AB budget line, consumer is demanding, let us suppose at this point, this is the point where consumer is demanding 2 units of good X, which we calculated. Okay, so obviously at this point, what would be, we would have an indifference curve that would be tangent to this point. Okay, and what is the corresponding indifference utility at this point? I am not drawing it. I will erase this to make the things more clear to you. So let us find out the corresponding utility. So utility will be equal to, at initial optimal bundle, so we have X, Y. So X is 2 units, Y is 5 units. So initially we are getting under root 10 utiles as the satisfaction, under root 10 at this point. Okay, now after, and what about good Y? We are getting 5 units. After that, what has happened in the second step? Price of good X has increased. With that, quantity demanded of good X has obviously decreased. Price of good X increased, quantity demand of good X decreased. That means quantity demanded, so we need to pivot the budget line towards left. We need to draw another budget line for obvious reasons, because price of good X has increased, quantity demanded has decreased. And let me try to draw the new pivoted budget line like this. Let us suppose this is AC is our new budget line. On this budget line, new AC budget line, we need to find out the new optimal bundle, okay, rather the final optimal bundle. So we got it as x is, and let us differentiate, let us say it is x prime to differentiate it from the initial point. So x prime is 1, we are demanding 1 unit of good x due to the price increase of good x. So let us suppose this is the point, okay, so this is 1 here, okay. Having said that, there will be a corresponding indifference curve here. I will not draw it here, I will draw it later to make this graph clear to you. The total effect of price increase has been, so the movement from 2 units of good x to 1 unit of good x, so this is our total effect. Now to find out how many units of good x has decreased due to the income effect and substitution effect. So how to decompose total effect into substitution effect and income effect? We need to draw a new budget line. And how do we draw that very thing? To isolate the substitution effect, we need to ask ourselves a simple question. What would be the consumer's optimal bundle if he or she faced new higher prices for good x but experienced no change in real income? That is to say, we need to find out the new compensated budget line. We need to find out the income that allows the consumer to achieve the initial utility. So initial utility he is getting, we need to reach, or we need to move the consumer towards the initial utility at new prices. Now what will happen at this? So we need to find out the compensated budget line. So what will be the compensated budget line? A budget line that will be parallel to AC. We need to draw a parallel budget line. Okay, so let me try to draw. So let us say this is, it will intersect, let us say this is PQ. PQ is called the compensated budget line. Okay, now we need to find out the optimal bundle on this compensated budget line. So for in the step 3rd, we need to equate MRS at new prices. So MRS we calculated as y upon x, and new prices are 10 upon 2. Price has increased. So we have here 5. So we have y is equal to 5x. Okay. Since we need to hold the initial utility constant and move the, okay, we need to hold the initial utility constant. What will we do? Since initially consumer was getting under root 10 utils. So what will we do? We plug, this is our initial utility, rather the given utility function, we plug u is equal to under root 10. So in place of u we have under root 10, and in place of y we write 5x in this equation. So we have x raised power 1 upon 2, in place of y we write 5x raised power 1 upon 2. So it will become x raised power 1 upon 2, 5 raised power 1 upon 2, x raised power 1 upon 2, or under root 10 will be equal to, so bases are same, we can add the exponent, so it will become x. So 5 raised power 1 upon 2 is under root 5, so we will get under root 5 and we will get x, or x will be equal to, dividing both sides by under root 5, we will get under root 10 upon 5, which is equal to under root 2. Okay, so under root 2 is 1.41 something. Okay, so to find out the new optimal bundle, we equate marginal rate of substitution at new prices, then hold utility constant. Holding utility constant means getting a utils of under root 10. So this is our x double prime, which is our 1.41. Okay, so when we, so let me write it here. So what we did here, so we have under root 10 is equal to x raised power 1 upon 2 then we have 5x raised power 1 upon 2, and when we solved it we got x double prime equal to 1.41. okay, now let me rub other things here. So where will be this point 1.41? It will be between 1 and 2. Let us suppose it is at this point. Okay, so this point, let us say it is here, it is a point 1.41. Now I can draw the indifference curve and explain to you. So we will have this kind of indifference curve, this kind of indifference curve. So this indifference curve is giving us a utils of under root 10. So the movement from this point to this point, okay, and for that, for this point we have already, or let us draw the indifference curve again. Now let me explain first here. So what is the total effect here? Total effect is the movement from this point, 2 units to 1 unit. This is our total effect. Now the movement from this point to this point, that means, or let me draw it here. So this 2 is our x, this one is our x prime, and this 1.41 is our x double prime. Okay, so the movement from, let me explain it here. What is the total effect? Total effect is the movement from x to x prime. So it is x is 1, rather the movement from, so what is the difference between x and this? So we got final is 1 minus 2, which is equal to -1. So total substitution effect is we have decreased 1 unit of consumption of good eggs. Now to find out the substitution effect of this, since we are on the same indifference curve here, so this point, the movement from this point to this point, it will denote our substitution effect. So substitution effect is x double prime, and we subtract x from this. So what is x double prime? X double prime is 1.41, and we subtract 2 from this, so we will get -0.586. so substitution effect is this 0.586. Now what about income effect? Income effect is the remaining effect. So the movement from this point to this point, okay, so let us suppose this is point E1, this is point E2, or let us suppose this is point E2 and this is point E3. The movement from point E3 to E2, it denotes the income effect. It is, so this point is x prime, and we subtract x double prime. So it will give us 1 minus 1.41. So it will give us, solving this, we will get -0.414. Okay. So what was the total effect now? Now total effect is equal to -1. Okay. Now this -1 is composed of two things, that is substitution effect and income effect. Here, how do I explain it now? If the price of good X has increased, consumer has decreased the quantity demanded of good X by 1 unit. So I am showing -1 here to explain the decrease in quantity demand. Now the decrease in the quantity demand of good X, since it is 1 unit, partly 0.586 units is because of the substitution effect, and remaining 0.414 units is because of the income effect rather. So our income effect, rather total effect of price increase, is equal to substitution effect plus income effect. Okay, so total effect has been -1, and here you can see substitution effect is -0.586 plus -0.414. Okay, now why did we draw this PQ line. This is a fictitious budget line. This budget line was only drawn here to isolate the substitution effect and income effect, or decompose the substitution effect and income effect. We call this the Hicksian budget line. Okay, so if I repeat it or try to repeat it quickly, what our question was. So we were given the initial utility function, rather the given utility function. We have only one utility function here, u is equal to under root xy. We are supposed to find out the substitution effect, income effect, and total effect when the price of good X has increased from $5 to $10 and price of good Y is 2 with the income of the consumer is 20. So to solve this question, we use 3 steps. First, we were supposed to find out the initial optimal bundle at initial prices. Solving them, we got the initial optimal bundle at this, where consumer was demanding 2 units of good X and 5 units of good Y. After that, second step was to find out the new or final optimal bundle at new prices. So price has changed. So in this budget line, price has changed. Here it was 5, here it has increased to 10. Now we found out that very new bundle that consumer was consuming of good X is 1. Here you can see initially consumer was consuming 2 units, now it is consuming only 1 unit. Why? Because price of good X is increased, quantity demanded of good X is decreased. Now to isolate, this is the total effect from 2 to 1. This is the total effect. Now to isolate this, what we did, to isolate or to find out the substitution effect and income effect, we ask ourselves a question: what would be the consumer's optimal bundle be if he or she faced new higher prices for good X but experienced no change in the real income? That is, where will be our optimal bundle be if consumer is able to reach to the initial budget, initially indifference curve. For that, what we did, we shifted the final budget line, that is AC, in parallel. Okay, we shifted it rightward parallel in such a way that this budget line is tangent to the initial indifference curve. That is, the utility of the consumer satisfaction remains same. So at this point, consumer is getting under root 10 units of utilities, and at this point also. Okay, when we find out this consumer optimal bundle at this point is X is equal to 1.41. Now the movement from E1 to E3, it is because of the substitution effect, because we are on the same indifference curve, and the movement from E3 to E2 is income effect. I hope I make myself clear in this video. So if you like these videos, please give your valuable feedback. You don't know how much time and effort it takes to make these videos, and how many retakes I had to take to draw the indifference curves legible or understandable for you people. Okay, so please share this channel, subscribe with your please subscribe and share this channel with your friends. That will be the only motivation for me to make more useful stuff for you people. So keep shining and stay blessed.